अच्छा, chemical equilibrium. अच्छा, what's पहले तो first thing, वो AS revision we have to do AS revision, और AS revision में कि it's mostly KCKP. अच्छा, basically what the chapter is about कि it's just applications of further applications of KC and KP. तो लेकिन पहले we have to revise all that we studied in O levels in AS level. ठीक है, so starting with the basic stuff, which is that what's a chemical equilibrium? Yeah, it's also known as dynamic equilibrium. What does it mean? It means that when the rate, दो तीन बातें, when the rate of forward reaction, अच्छा, they're going to ask this again in A2 as well. अच्छा, when the rate of forward reaction equals rate of, अच्छा, equals rate of backward reaction, और ये AS की रिवीजन है, मैं जल्दी करने की कोशिश करूंगा, तो of backward reaction in a reversible reaction. That's the first point. The second point is कि it's the concentration of the reactants and products stops changing. So the concentration of your reactants and your products, it stops changing. So you've got your reactants, you've got your products, the rate at which your reactants are changing into products and the rate at which the उसको P होना चाहिए था. अच्छा, the rate at which the products are changing back into reactants, that's the same. Okay, so you don't see any change happening. Like if you have 4-5 particles of this and you have 10-12 particles of the product, so if two particles convert into products and at the same time two particles convert back into reactants, that would mean there would be no net overall change in the reactants and products. Okay, so okay, you already know this. So that's what an equilibrium is. Then there's the Lee-Shatler principle, which is that fellow definition of Lee-Shatler principle. Okay, the equilibrium moves around. It's not static. Sometimes the forward reaction, you make a change and the forward reaction increases in speed, and sometimes the backward reaction becomes faster. So that is the Lee-Shatler. That is the effect is defined by the Lee-Shatler principle, which is कि वो क्या होता है कि the equilibrium opposes any change that's introduced to the system. वो अक्सर इस definition में भी ना कि it's एक और भी लिखा होता है that you need to have closed system because you don't want the equilibrium to move around. अच्छा, ली शैटलर प्रिंसिपल है कि equilibrium opposes any change introduced. ठीक है, या specifically dynamic equilibrium opposes any change that's introduced into the system. And अच्छा, it has three rules. One is that rule number one, कि increased temperature, what happens? The endothermic reaction. अब मैं इसकी डिटेल में नहीं जा रहा. Increased temperature, endothermic reaction speeds up. ठीक है, everyone should know that कि जिसको energy चाहिए ना, the one that needs energy, that will speed up. The second one is well, the opposite one, that's decreased temperature. तो वो उल्टा हो जाएगा. It's going to favor the exothermic reaction. Now, the next one is if you increase pressure, so less gas mole side is favored, or less gas is produced. Increased pressure, less gas mole side is favored. And sometimes they refer to in pressure as decreasing volume. That means the same thing. कि गैस का वॉल्यूम डिक्रीज करोगे ना तो you're obviously increasing pressure. The second point of this is that the opposite one, you decrease pressure. So that means you're increasing, vice versa, you increase volume. The more gas mole side is favored. As the last one is, the very last one is that if you increase or decrease concentration, तो क्या होगा कि what's going to happen is that the equilibrium does the opposite. So I'm going to do one example of moving the equilibrium right or left. Or what typically O level से चलता आ रहा है, ठीक है, you did this in AS as well, that's N2 and H2, and they're reacting and they're producing NH3 gas, and it's an exothermic. The enthalpy change is always for the forward reaction. That means that the forward reaction is exo, or जो backward है ना, that's going to be endo. ठीक है, so remember the enthalpy change is the thing that determines it determines what the forward reaction is. So all of them are gases. Now, if I decrease temperature of the system, what is the rule? The rule states that if you decrease temperature, that means exothermic reaction is favored. And the exothermic reaction in this case is the forward reaction. Okay, or remember, so forward reaction is going to be favored. इसका मतलब equilibrium shifts to the right. ठीक है, vice versa, if I, let's say, increase pressure. So what is the rule? The rule is that if you increase pressure, less gas mole side is the side which has fewer gas moles, because if you're increasing pressure, you're compressing it. So less gas would be produced. Now, on one side, you have 4 moles of gas. And on the other side, you have 2 moles of gas. So which side is your less gas mole side? That's obviously your forward side. So hence, forward reaction is again. It's again favored. So the third one is that if you, let's say I decrease the concentration of H2. Square brackets is concentration. So if I decrease concentration of H2, what does the equilibrium do? Equilibrium is going to do the opposite. Equilibrium it does the opposite. And tries to increase the concentration. So it tries to increase the concentration by doing what? By producing more H2, which means that it will go in the backward direction. It's going to try and produce more H2. That is how it's going to increase the concentration. So hence your backward reaction is going to be favored. Okay, is this clear?
Yes.
अच्छा, अब ना I'm just going to do some basic Lee-Chatelain principle. ठीक है, I'm just going to do some past paper questions. क्योंकि वो सब उन्होंने ए लेवल्स में भी पूछना है, ठीक है? जस्ट वन सेकंड, लेट मी शेयर माय स्क्रीन और पास पेपर्स खोल। अच्छा, ये ली शार्टर प्रिंसिपल। अच्छा, इसके ना मुझे ट्राई एंड आंसर दीज क्वेश्चंस के uh, अच्छा, द क्वेश्चंस can be tricky. It's not going to be that straightforward. ठीक है, just remember increased temperature endothermic, decreased temperature exothermic. Increased pressure less gas, decreased pressure more gas. Increase concentration of something, it will try to do the opposite. It's going to decrease it. If you decrease it, it's going to do the opposite. अच्छा, एक क्वेश्चन कर लेते हैं। वो कह रहा है स्विमिंग पूल वाटर कैन बी केप्ट फ्री ऑफ हार्मफुल बैक्टीरिया बाय एडिंग sodium chlorate 1, which is जो भी NaOCl. This reacts with water to produce HOCl molecules. ठीक है? So it produces HOCl molecules. In bright sunlight, sunshine, the OCl ions which were produced, they break down by ultraviolet light. The first one is a reversible reaction. The second one is not a reversible reaction. Which method would maintain the highest concentration of HOCl? So you want the maximum concentration of HOCl. वो ज़्यादा करनी है. So what will happen if you acidify the pool water? So if you add acid to pool water, so what is going to happen to the reaction? Now, if you add acid to it, अच्छा किसी को पता है कि क्या होगा अगर अगर acid add करें? हाला क्या होगा मावा? Anyone else? Minal क्या होगा if you add acid to the? What will happen to these reactions? If you add acid to it. ये स्क्रीन शेयरिंग बंद हो गया? अच्छा हो गया. अच्छा, if we add acid to it, so remember that acid is going to react. Acid has H plus 1 ions. And those H plus 1 ions are going to react with OH ions. And they're going to neutralize the alkali. Okay, so if you add acid to it, your OH ion concentration will decrease. Okay, when you add acid to it, your OH ion concentration is going to decrease by a lot. And screen नजर आ रही है ना सारों को?
आगे वाले में
अच्छा. अच्छा, so if you add acid to it, your OH ion concentration would decrease. So OH ions, if the OH ion concentration decreases, where will the equilibrium shift? It will try to increase the OH ion concentration. So it's going to shift forward. And when it shifts forward, that will produce more HOCl molecules. So the Canada would maintain the highest concentration of HOCl. I think option A is the correct option. ठीक है, तो indirectly how it affects it, you add acid to it, it will neutralize the OH ions, and obviously acid alkali को neutralize करता है, it will neutralize the OH ions, and your OH ion concentration decreases, and your equilibrium is going to shift in the forward direction. ठीक है? As the next one, okay, what will happen if you increase what statements are correct? If you increase the pressure, the equilibrium yield will increase as well. अच्छा, if you increase pressure, तो कौन सी side favor होती है? The side that has fewer gas moles. If you increase pressure, fewer gas mole side is favored, which is either कितने moles हैं? 3 moles, and on the other side you have 2 moles. So it will favor the forward side because so more SO3 will be produced, and that first statement is correct. यहाँ पे less gas है. This side has less gas. If you increase temperature, अच्छा KP की अभी बात नहीं करते. अच्छा, what does a catalyst do? अच्छा, catalyst का I'm going to add this in the notes as well. A catalyst does not affect the equilibrium position. It does not increase the yield. It just speeds up both reactions equally. हमने दो बातें अभी डिस्कस करनी है, which वो भी हम करते हैं इसके बाद. थोड़े से क्वेश्चंस कर लें. तो remember, a catalyst speeds up both reactions equally. और मैं ज्यादा नहीं करूंगा, मैं एक आध ही करूंगा. Or question. Which statement about reversible reactions are correct? An increase in concentration of reactant always increases the concentration of the product, which is correct. कि अगर आपके पास, if you have reactants, you've got products, you increase the concentration, the equilibrium will try to decrease it, and it will decrease it by making more products, which is correct. So the first statement is correct. An increase in temperature always increases the rate at which the equilibrium is established. That is also correct. ये भी हमने discuss नहीं किया, वो rate पे आ गया. But whenever you increase temperature, the rate is always higher. An increase in temperature always increases the concentration of the product, which is not correct, because always is not correct. Because when you increase temperature, which reaction is favored? The endothermic reaction is favored, and the endothermic reaction could be the forward reaction. It could also be the backward reaction. So it depends. वो वेरी करता है, ठीक है. तो अच्छा, मैं वापस आ रहा हूँ. आई जस्ट वांटेड टू अ कपल ऑफ क्वेश्चन. अच्छा, इसके ऊपर और तो नहीं करना ना, बिकॉज वी ओ लेवल से करते आ रहे हो ये. चलिए, ये क्लियर है. उमर वैसा हाला इज क्लियर. मिडिल क्लियर है.
Yes.
अच्छा, so equilibrium. The next thing we're going to jump to is वो catalyst वाली बात ऐड करते हैं. Remember adding a catalyst. Does not affect. It does not affect equilibrium position. The only thing it does is it speeds up both forward and backward reactions equally. ठीक है, that is what a catalyst would do. Now, the more important thing is where people get a lot of confused when they are doing questions is never mix equilibrium and a comment on equilibrium or equilibrium and rate. Yeah, they're completely two different things. What is rate? Rate is something that is going to, I mean, rate is the speed of reaction. It increases. When what happens? There are 4 or 5 factors which would increase it. One of them is temperature. There is pressure, but that is for gases only. You can remember pressure का काम gas के साथ है. Otherwise, pressure has no effect on solids or liquids or solutions. It only applies to gases. Concentration, similarly, is something that is a term that's only associated with solutions or sometimes gases. You've got catalyst and surface area. Now, these are the factors that will affect the rate of reaction. They'll speed up the rate of reaction if you increase these factors. But you're never going to mix a comment on equilibrium and a comment on rate. They're completely two different comments. Okay, for example, if I have a reaction and I have N2 plus 3H2 and we will reaction, I've got it's forming 2NH3 and it's an exothermic reaction. The forward reaction is exo and your backward reaction is endo. अब होगा ये कि if I tell you that what will happen to the equilibrium if I decrease temperature? So you're going to state if you decrease temperature, and remember this is at the moment I'm asking about the equilibrium position. So if I लिख भी देते हैं, so I want to know what's going to happen to the equilibrium? So if you decrease temperature, what happens? Exothermic reaction is favored, which is the forward reaction in this case. So the forward reaction. Assessment, I'm going to add a term which is relatively speeds up. Because, so if I write, if the forward reaction speeds up, that does not necessarily mean that it's actually speeding up. Okay, what could happen is if they simultaneously start asking about the rate of reaction, then remember that whenever you decrease temperature, the fact is molecules lose kinetic energy. And both forward and backward reactions are actually decreasing in speed. Because they both decrease in speed. So remember this, that an equilibrium is a relative comparison. It just tells you, okay, one of the reaction is, if the forward reaction relatively speeds up, it just means that the forward reaction is relatively faster compared to your backward reaction. It doesn't mean that it's actually getting faster. It just means that the forward is actually relatively faster compared to, because whenever you decrease temperature, both reactions are actually decreasing in speed. So they're both actually slowing down. But a common equilibrium is going to suggest which one is relatively faster compared to the other one. Okay? तो ये याद रखना, whenever you read questions, be very careful whether the question is it's about equilibrium or is it about the rate of reaction. ठीक है? Rate में होता है कि either both reactions speed up or both reactions are slowing down. But equilibrium is one of them is still relatively faster compared to the other one. Okay? That is what is determined by equilibrium. Okay? So don't mix these two things up. ये बात clear है सारों को? Hala, is this clear? Umar, Mama, is this clear? Middle clear है?
Yes.
Yes, sir.
अच्छा, अब नेक्स्ट चीज पे जा रहे हैं, ठीक है? You already pretty much you've studied this often. Now the next thing is that mostly O levels यहाँ पे खत्म हो गया था, that you had forward and backward reactions, right? The next thing that we're going to discuss is which is AS specifically, and that is equilibrium constants. ठीक है? अच्छा, so A levels में you'll also be discussing equilibrium constants mainly. ठीक है? That is still going to be parts of, so basically we'll just be studying different applications of KC. C stands for concentration over here. This is specifically the input over here is concentration. Now, whenever you have a reaction and it has reached equilibrium, अच्छा एक याद रखना, KC can only be calculated for reactions that are already at equilibrium. Something that is not at equilibrium, you can't calculate KC for that. So KC is for systems that have reached equilibrium. So you've got reactants and you've got products, and there's a reversible reaction. So what is Kc? Kc is the ratio of the concentration of the products. Remember, square brackets is concentration divided by reactant. So it's the ratio. If you have a very high value of Kc, that means the equilibrium has more products. I mean, there are more products present at equilibrium, and there are fewer reactants at equilibrium. and their concentration is not changing because the rate of forward and the rate of backward is exactly the same. So, so Kc greater than 1 indicates more products. The equilibrium favors products. You got more products at equilibrium. As a similarly, Kc less than 1, a smaller value of Kc, that means the reactant concentration is pretty high and the product concentration is not very high. So in that case, Kc less than 1, you're going to have less products at equilibrium. Okay, so you've got two situations, and if Kc is exactly equal to 1, that would just mean that you have a perfect equilibrium. You're right in the middle. Okay, the concentration of the reactant and the products are very similar. So it depend करता है. I mean, I can show you an equilibrium system. Okay, that equilibrium system is, let's say you have very little water. There's water liquid. And there's steam. So you can have very little water and there could be a lot of steam or water vapors, but the system could be at equilibrium. Or there might be more water liquid and there's going to be less water vapors. Even then it would be at equilibrium. Okay. So it depends. Different systems have different equilibrium positions. So the good thing about Kc is that Kc is always a constant. Okay, this thing is always a constant and there's only one thing that changes it. So always a constant and only changes with temperature. Okay, that is the only thing that will change the value of Kc. Now, the other thing is that what type of questions do you get on Kc? Kc has, for Kc, you get 3 different questions. One is they're going to ask you about writing the expression for Kc. Okay, so that's question number 1. And they'll ask you to calculate the units as well. So that is question number 1 on Kc. So if I have a reaction and it's let's say 2SO2 plus O2, and it's 2SO3. Okay, so you've got this equilibrium reaction. So Kc is product concentration divided by reactant concentration. Now the product is SO3, but remember the coefficient becomes the power. At the bottom it's going to be SO2, and the coefficient becomes the power, and the other reactant is O2 and its concentration as well. So this is your expression for Kc. And they're going to ask you about the units for Kc as well. The units for Kc in this case would be concentration. I'm going to take concentration. Just for simplification, I take mole per dm cube as x. So it's concentration squared divided by concentration squared into concentration. And that will give me, if I simplify, that's going to give me x to the power minus 1. Now, if I substitute x over here, which is mole per dm cube, it's going to give me mole minus 1 and dm 3. Okay. So that's the first question that you're going to get on Kc. और जो हम बाकी constants करेंगे ना बाद में, that will also, it will be the same situation. So that's what Kc is. Product concentration, we're going to do some questions on this. Product concentration divided by reactant concentration. The second type of question is calculating the value of Kc. Now, usually what happens is that the question is written in this way. You say SO2 with a questionnaire, they would say that, they would say something like this, that 2 moles of SO2 and 1 mole of O2 are mixed in a container. And when they're mixed in a container. After some time, once equilibrium is established, it is found that container has 0.15 कितना करें 0.18 कर लेते हैं 0.18 moles of SO3. Okay, that's good enough. The container volume, let's assume, is 1 dm cube. So what you're going to do is, every time you get this question, you have to draw a table. So you have your reaction, which is SO2 plus O2, and it's in equilibrium. Here you've got this reaction going on. You have the initial situation, and you have the equilibrium situation. The initial situation is you had added 2 moles and 1 moles of O2. So 2 moles of SO2 and 1 mole of O2 was added. They did not initially add any SO3. That means kiske moles kitne hue? That's going to be 0 moles. You don't have any SO3 initially. So then what happens is that he says that equilibrium gets established. Okay, so the equilibrium is established. And it is found that you have 0.18 moles of SO3 at equilibrium. Okay, so you found that out. Now, based on that, you have to now figure out what is the amount of moles of SO2 and O2 at equilibrium. So what you're going to do is you're going to start at this point, which is maybe 0 moles there initially, and now you have 0.18 moles, right? So that means since initially you didn't have any moles, and now you have 0.18 moles, that means 0.18 moles got produced, right? They were added, they were produced, they plus were. So that means 0.18 got produced, but the plus 0.18. So based on the ratio, remember the ratio is going to be applied to this. It's not going to be applied to the initial moles or to the final moles. It's going to be applied to the amount that is getting produced or reacting. So जो बीच वाला part है ना reacted or produced. That is going to tell you what is the amount of reaction that's happening. So 0.18 got produced, right? So it's 2:1, right? So if 0.18 are getting produced, that means if according to 2:1, that means कि यहाँ पे क्या होगा? It's going to be 0.09. That would be reacting, right? So half of that would have reacted, right? And since it's 2:2, that means 0.18 must have reacted over here as well. So it's pretty straightforward. Okay? Once you have initial moles and you have final moles, you can simply check, okay, this is the amount that is getting produced. Okay, that's the amount that's getting produced. And according to 2:1, if 0.18 got produced, 0.09 must have reacted. And if 0.18 must have been produced, 0.18 must have reacted as well. Okay? And using that, you can now find out your equilibrium moles, which are के 2 थे ना, तो your 0.18 is gone, so what do you have? You have 1 point, क्या होगा? 1.82? And 1 and 0.09 is gone, so you have 0.91 moles, right? So that's the amount getting produced, and that's the amount that is getting, that's reacting. ठीक है, is this clear?
Yes.
Okay, once you have equilibrium moles, you can plug these values into your Kc expression. Now it's important that you don't plug in the values of moles in the expression. You always use concentration, and concentration is moles over volume. So 1.18 moles. I told you the volume was 1 dm cube, so it's going to be 1 dm cube, or so it's going to give you the same result. So everything, that's why I used a 1 dm cube container, so that when I divide by 1 dm cube, I pretty much get the same answer. And I can now plug those values in the expression, which is the SO3 concentration, and that's squared. That's power 1. So it's 0.18 squared divided by 1.18, and that's also being squared, and into times O2 कर लो 0.91. ठीक है? So you'll find the value of Kc. तो इसके questions जो है ना practice करेंगे, because this is important. So we'll practice past paper questions related to Kc in the next class. एक और type का भी question होता है. Mostly you get these types of questions. There's a reverse question as well, which is ये reverse में you do the opposite. You have the reverse में you have the Kc value already, and you have to find the equilibrium concentration in reverse. ठीक है? तो चलिए ठीक है, ये हम ना कल पास पेपर्स करते हैं इसके Kc के, और कल ही कंटिन्यू करते हैं. ठीक है? तो चले, ओके, अल्लाह हाफिज.